rest of this week is proving triangles congruent. And we talked about congruent figures and triangles through transformations earlier on in the year, but we're going to take a look at how it looks on just paper without being in the coordinate plane. And we know triangles are congruent if they have the same sides and angles. So if all three corresponding sides are the same and all three corresponding angles match up, then those triangles are congruent. This is known, and we'll talk about this much later, as CPCTC, corresponding parts of congruent triangles are congruent, meaning if all 6 parts, all sides and all angles are congruent, then the triangles have to be congruent. Okay? If you remember from transformations, when we state that two things, why are these moving? When we state that two things are congruent, or two triangles, it depends on the order of how the vertices are written. Okay, so we have two triangles, A, B, C, and triangle E, F, G. Everything is congruent based off the order that the vertices are written in the congruent statement. So if triangle ABC is congruent to triangle EFG, that means, and we'll do angles first, angle A is congruent to which angle? To the other triangle. E. Angle A is congruent to angle E because they're written first. Okay? Angle B then is congruent to what angle in the other triangle? F, because they're written second. And then angle C is congruent to which angle is written in the other triangle? G, because they're both written third. That can help us determine which sides are congruent, because if you look here, this side, AB is in between one arc and 2 arcs. So which side is AB congruent to in the other triangle? Yeah, because it's in between 1 arc and 2 arcs. So we can say that AB is congruent to EF. Okay. If you notice the order they're written, AB is the first 2 letters, EF are the first 2 letters. So that's why they match up. Okay? We go back to the first triangle, BC is in between 2 and 3 arcs. So BC has to be congruent to what side? FG, because it's in between 2 and 3 arcs. And again, we talked about this. Kind of we did transformations and similarity. I wrote this on order. BC is congruent to FG. Okay. And then finally, AC has to be congruent to what? EG. 1 arc, 3 arcs, 1 arc, 3 arcs. Also, if you notice, A is first and C is last. E is first and G is last. So looking at the order of how they're written is helpful for determining what parts are congruent to each other. Okay? It's also very important that when we state that things are congruent, you go in the correct order. So we wrote it AC. A has 1 arc, C has 3 arcs. You have to name the next segment in that same order. EG. E has 1 arc, G has 3 arcs. So order matters when you're stating that things are congruent. You have to go in the same order. That's the important thing. Okay. To take a look at some examples, we want to determine if the following triangles are congruent. If they are, write a congruent statement. Okay? And we just said in order for triangles to be congruent, all 3 sides and all 3 angles have to match. Okay? Well, I'm going to look. This side has 1 tick mark. That has 1 tick mark, so they match. 2 and 2, 3 and 3. Same thing with my angles. 1 arc, 1 arc, 2 arc, 2 arc, 3 arc, 3 arc. So looking at that, do all the sides and angles match up? Yes. Can we say that these triangles are congruent? Yes. When we write a congruent statement, I just look at the top triangle. How do we want to name that top triangle? It does not matter. However you want to name it with those vertices. ABC. Okay? How we name the second triangle matters. We name the first one ABC. 1 arc, 2 arc, 3 arc. How do we have to name that second triangle? Yeah. 1 arc, 2 arc, 3 arc. Are my two triangles in B congruent to each other? Do all three sides match? Yeah, all three sides match. Here's a side with 1 tick mark. Sides with 2 tick marks, sides with 3 tick marks, so our sides match up. We have all three angles that match. Are all three corresponding angles congruent? I see 2. I see that E has 1 arc and A has 1 arc. D has 2 arcs and B has 2 arcs. That's why I only see 3. I only marked 2 angles for me. How do we know that these are congruent, Trent? Yeah, what kind of, well no, that's if that's similarity. So if we were saying similar, you'd be right. Yeah, we know that this angle and this angle are the same because they're vertical. So now all three angles match and all three sides match. So now we know that these triangles are congruent. So we would say yes. So we would say triangle. How do we want to name this top triangle? Doesn't matter. You could have named it BAC or CDA. Does not matter. ABC. How you name the second one does. We went from 1 arc, 2 arc to 3 arc. Follow that same pattern. How do we have to name that second triangle? And this main part is just to talk about naming things congruent and how you have to go in order. Order matters. And then follow the same pattern. Go ahead. Try. I just want to make sure. Okay. Didn't pass it out when you got it. Try these on your own. Give you like a minute or two. Determine if they're congruent. Again, to be congruent, all three sides have to be the same. All three angles have to be matched up. They are congruent. State a congruent statement. They're not congruent. Not enough info. To determine if they're congruent. Like a minute or two. Try. What did we conclude about A? Are these two triangles congruent? We would say, yeah. All three sides have the same tick marks. All the angles have same tick marks. So we can say that they're congruent. So we can write a congruency statement. Okay, name the first triangle. Name this first triangle on the left. ABC. So we name that triangle. We can say triangle ABC is congruent to, we went from 2 to 1 to 3 arcs. How do we have to name the second one? Yeah, 2 to 1 to 3 arcs. So that's for A. What about B? Did we have enough information to determine if they're congruent? Oh. Yep, sorry. DEF, not EDF. DEF. Sorry. We went from 2 to 1 to 3, 2 to 1 to 3. Okay. What about B? Do we have enough info to determine if these triangles are congruent? They might look congruent, but did they specifically tell us enough info? Nope. They only told us that 2 sides were the same. And they only told us that 1 angle. But remember, in order to be congruent, you have to show that all 3 corresponding sides are the same and all 3 corresponding angles. Even if they look the same, you can't assume it unless you're told information that can lead you to it. Okay? So not enough info, we can't really state if these are congruent or not. Not congruent or not enough info. We just can't, based off what they gave us, we cannot conclude that they're congruent. They might be, but we just can't. Okay. What about C? Are those triangles congruent? Yeah. The sides have the same tick marks. 1, 1, 2, 2, 3, 3. Okay? And the angles have the same marks. 1 arc, 2 arc, and they both have a 90-degree angle. And remember that box needs 90-degree angle, so their angles match and their sides. So now we can write a congruency statement. How can we name this first triangle? Doesn't matter. ABC. Triangle ABC. Congruent to. Triangle, we went from ABC, 90 to 1. Follow that same pattern. How do we have to name this next one? PQR, 90 to 1. Questions over that? I feel like we've done this first part of just kind of a refresher on how to name things congruent. Okay? You have to go in order. Okay. In the next section, we are going to talk about proving triangles congruent. So Trent mentioned this earlier. When we've talked about proving triangles similar, we first went through the whole process of showing that all three angles are the same, all three sides are proportional, this long process, just like we did on the front. But then we learned a shortcut to make our lives easier. Okay? Well, there are tons of shortcuts that we can use to show that triangles are congruent, rather than seeing that all three sides and all three angles are the same. We can use these shortcuts. Okay? And we're going to talk about two of the shortcuts today, and then we'll talk about the other two on Friday. Alright, but the two shortcuts we're going to talk about today are side, 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 and side angle, side. Okay? There's some vocab we got to get into before we get into the shortcuts. And those shortcuts allow us to only have to show that three parts are congruent rather than all six. Okay? So it makes life a little bit easier. So we take a look here. First vocab word is included angle. And that's the angle formed by two sides of a triangle. So if we look at this example, so again, include an angle, the angle formed by two sides of a triangle. So we have side PR, this purple line, and we have side PT. Which angle is formed by those two sides? Angle what? Angle P. So that is the included angle. I like to think of it, it's the angle in between two sides. So we have the purple side and the green side, the angle in between is P. Right? That's going to help us with one of our shortcuts. So, side, 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 SSS, stands for side, side, side. Okay? That is if three sides of one triangle are congruent to three sides of another triangle, then those triangles are automatically congruent. So rather than having to show all the sides and all the angles, you just have to show that all the sides are the same. And if they are, then those triangles are congruent. Side angle side says that if you can show that two sides and the included angle, so the angle in between of one triangle, are congruent to two sides and the angle in between another triangle, then those two triangles are congruent. Okay, so those are shortcuts. So rather than showing all six of those pieces, you just have to show three. Either all three sides or two sides with an angle in between. If we can do that, then we know those triangles are congruent. Questions over that? We'll see some examples here in a second. So we're going to determine if these triangles are congruent using those shortcuts. Okay? So if we take a look here, I have a side, and here's another side, here's another side, and the angle in between. Okay? How, or can we say that those triangles are congruent, and if yes, how? Which shortcut can we use? Based off the info we have. We have two sides and an angle in between. How can we say that they're congruent? Trent? Well, which are those shortcuts? We talked about two of them. Is it showing that all three sides are the same? Or is it showing two sides with an angle in between? Okay, there's two sides with an angle in between. So which shortcut is that? side, angle, side, right? We have a side, we have an angle, and we have a side. We have a side, then we have an angle, then we have a side. Side, angle, side. Two sides and an angle in between. If we can show that, then we know they're congruent using that shortcut. Side, angle, side. Let me take a look at B. We have a side. Okay, it's congruent to this side. We have another side, so we're good there. But are the angles in between those two sides the same? No. Right? The angle in between this first triangle is congruent. But is there a tick mark with the angle in between and the second triangle? No. So we cannot say that they're congruent by side, angle, side. Did they tell us that the third sides were the same? Are there tick marks on the third sides? No. So can we use side, side, side? No. So can we say that these triangles are congruent? No. Okay, not enough info to conclude that they're congruent. Okay. If we take a look at C, well, I have two sides here. Here's a side that are the same. Here's another side. Did they tell us if any angles were the same? No. Do we know if the third side's the same? Yeah. What? How do we know that that's the same? They're sharing it. Yeah. They're sharing that third side. So obviously, it's the same. That side is equal to itself. Right? So whenever they end up sharing a side, that side is congruent in both of those triangles. So what shortcut can we say allows us to say that these triangles are congruent? Side, 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 or side, angle, side? Side, side, side. We showed that all three sides are the same. Questions over that? So now, we're going to apply this to a proof. So we're going to complete the following two-column proof to show that these two triangles are congruent. We're trying to prove that triangle JAD is congruent to ZAM. Just like we filled out every single proof, what's our first statement and reason every single time? Given. So we were given that JA is congruent to ZA. And we were given that A, you can abbreviate, is the midpoint of DM. Okay, and our reason's given. Every time. That's your freebie. What's your other freebie? What's your last statement every single time? What you're trying to prove. And we're trying to prove that triangles are congruent. So your reason's going to be one of those shortcuts we just talked about. It's either going to be side, 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 or side, angle, side. It's one of those two. We don't know which one yet. We have to go through all their steps. But it's going to be one of those two. So at the end of the day, if you have no clue, pick one. You might be right. Okay? Don't leave a blank. It's going to be one of those two. 50-50 shot. We just don't know yet. Okay? What you're going to do next is look at all your given information. They told me that JA is congruent to ZA. If it's not already marked for you, you need to mark it. They were really nice and marked it for us. So we took care of that. Check. If it's not marked, you have to mark it in your diagram. You have to. Or else you're not going to know which shortcut you use. You have to mark your diagram. You have to, you have to, you have to. Okay? So they go to your other bit of information. We were told that A is the midpoint of DM. I have a vocab word. I have a sentence with a vocab word in it. Okay? What's one of our reasons going to be? Definition of a midpoint. Whenever that happens, vocab word. Your reason is going to be definition of a midpoint. Or whatever that vocab word is. every time. Okay? And also what I like to do with these triangle proofs, I put my reasons first. I figure out my reasons. And then I go back and fill in my statements. Because once I get my reasons down, my statements come into play. Okay? So I'm going to hold off on putting my statement for that reason, but I know that's a reason. Okay? My third reason is another freebie when you have these type of triangles. What do these triangles look like to you when you look at them? A bow tie. Yeah, like a bow tie. Or bow tie pasta or bow tie that you wear when you want to be fancy. Okay? These are what we call bow tie triangles. And whenever you have bow tie triangles, one of your reasons, like 98% of the time, sometimes we don't need to use it. You could, but we don't need it. Okay? Is vertical angles are congruent. Okay? Vertical angles are congruent. Every single time, whenever you're given bow tie triangles, 98% of the time, that's going to be your automatic reason. So I'm going to put that as my reason. Vertical angles are congruent. Every time. 98, 99% of the time. Sometimes they give us enough information we don't have to use that. Sometimes, most of the time, we do. Okay? And it doesn't matter. You could have flip-flopped them. You could have put vertical angles are congruent as number 2 and definition of midpoint as number 3, and you're still right. Okay? Sometimes that can happen. You can flip-flop things and improve, and you're still correct. Okay? So now, we fill in our statement. But using those shortcuts, knowing that your first statement is the given and your last statement is what you're trying to prove. Seeing a vocab word and putting definition of that vocab word. Seeing bow tie triangles and putting vertical angles are congruent. You filled in more than half of that proof. You're more than 50% right by just remembering those shortcuts. Okay. Make sure you follow those shortcuts. Okay. Well, let's fill in our statements. Start thinking about what does it mean to be a midpoint? It's saying A is the midpoint of this line DM. What can we conclude from that? If A is the midpoint of DM. DA equals AM. Yeah, DA and MA are the same. Okay? We can say DA is congruent to MA. You have to be very careful. We talked about on the front. Order matters when you're stating things congruent. So if we said DA, we went from out to in, you have to name the statement the same way. Out to in. Okay? Again, most of the time we're going to have a word bank, so you just have to find it. But just in case you don't have a word bank, order kind of matters. But I'm not picky about it, because like on your OST and stuff, you have a word bank. So just look for that statement in your word bank. Okay? Stating that those two segments are the same. Let me make this look a little nicer. Okay. Then my next statement, I said vertical angles are congruent. Well, look in your diagram and just state what the vertical angles are. Here are my vertical angles. Name this first vertical angle. Doesn't matter. How do we want to name it? Well, we can't say that. I like that you said that, though. Because there's 1, 2, 3, there's 4 different angle A's. So you have to use that 3-point method to name the angle, since there's more than one angle A. So how do we have to name it? Angle J A what? D. Angle JAD. Is congruent to. Again, order matters. We went from JAD. We went from 2 ticks to 1 arc to 1 tick. Follow that same pattern. We went from 2 to 1 to 1. How do we have to name this other vertical angle? Yeah, VAM. 2 to 1 to 1. This is why it's super important to mark your diagram. That's telling you which of these shortcuts you use. How did we mark our triangles? Are we going to did we mark 3 sides congruent? Or 2 sides with an angle in between? 2 sides with an angle in between. So we are going to, as our reason why these triangles are congruent, are side angles. We have a side, then an angle, then a side. Side, angle, side. some practice, so work on the practice tomorrow too. Questions? One more. Oops. Oh, I didn't erase this from last class. Okay, so now we're given triangles, and we have to prove that triangle QRS and triangle STQ are congruent. So do your freebies. What are you going to put first? Given. Always put it first. RQ is congruent to TS, and RQ is parallel to TS, and that's always given. Again, what's our last statement? What you're trying to prove. QRS is congruent to triangle STQ. And we know one of our reasons has to be this. We just don't know which one it is yet. But if you're unsure, pick one. 50-50 shot right now. We'll learn 2 more this week. But still, pick one. That's right. But we can fill in the rest of our proofs to know if we're right or not. So again, look at your given information. I'm told that RQ is congruent to TS, so I'm going to mark that in my diagram because it's not marked for me. Mark your diagram. Okay? Took care of that given information. I marked my diagram. Okay? Did they give me a sentence with a vocab word as my given information? No, they didn't. So we are not using definition of vocab word in this shortcut. They didn't give me a vocab word. They didn't give me a sentence with a vocab word in it, so I can't use that shortcut. Okay? But there is another freebie they gave me. We were told that RQ is parallel to TS. And like, again, 99% of the time, when you are given that 2 lines are parallel in a proof, your reason is going to be alternate interior angles, are congruent. So another freebie is you're told, hey, I have parallel lines. I'm going to say that these angles are congruent. Alternate interior angles are congruent. Every single time you are told you have parallel lines in a proof, alternate interior angles are congruent. That is another freebie. Again, I fill my reasons in first, then I go back and fill in my statements. Because your reasons are pretty much freebies every time, if you remember these shortcuts. Okay? Another freebie is we took care of our given information. Then look and see what type of triangles are these. These are what we call, we've already kind of talked about them, we call them shared side triangles. Because they share that middle side, it's going right down the middle. Okay? So whenever you have shared side triangles, they're connected with a side going down the middle of them. Your reason's always going to be reflexive property. Every time. That is another freebie. Whenever you have shared side triangles, one of your reasons every time is reflexive property. Freebies. Those were all free. You just remember those shortcuts. You really didn't have to think. You just had to see parallel lines, alternate interior angles are congruent. Oh, these are shared side triangles, reflexive property. That's all you had to do. And you filled in more than half that proof. And then you have a 50-50 shot of getting the 4th reason. You just happen to guess the right one. Okay? Freebies. Not that bad. You just have to remember these shortcuts. Okay? And you remember them by doing them a lot. Okay? So we're going to spend a lot of time on these proofs so you can get those shortcuts down. But once you get your reasons filled in, go back and fill in your angles. Okay? To figure out what your alternate interior angles are, what I like to do, okay, is take my pencil and start with the line R. I'm saying RQ is parallel to TS. So I highlight RQ. I go down the side that's in the middle and go up. So I make like a Z or an N shape. Okay, like that. those angles in your corners are your alternate interior angles. Okay? So my alternate interior angles are the ones that are in my corners. Those guys right there. Just make your Z or make your N depending on how it's oriented. Go like that. And then in the corners, those are your alternate interior angles. Okay. So we just have to name what those are. I'll name the first one. I'm going to name that RQS. I went from end to one arc to nothing. One tick mark, arc to nothing. Okay? Follow that same pattern. If we want RQS, how do we have to name that other angle? TSQ. Follow the same pattern. Arrow to arc to nothing. Arrow to arc to nothing. Okay? TSQ is congruent to TSQ. And again, you're going to be given a word bank, so just look for the names of those two angles saying that they're congruent. Okay, you have to be able to look in a box and say, okay, these two are naming those two angles, that's what I'm going to put. Okay? Here's another freebie. Okay? Whenever you have shared side triangles, your reasons reflexive property. Okay? And that is just stating that the shared side is congruent to itself. Another freebie. Shared side triangles, your reasons reflexive property, and your statement that goes with that is just saying, hey, that shared side is congruent to itself. Another freebie. Just using those shortcuts. So just knowing those shortcuts. You filled in 1, 2, 3, 4, 5, 6 steps of those 8, and then you have a 50-50 chance of getting that one right. So really, knowing those shortcuts, you're filling everything in but one thing in that proof. So no one should be leaving these blanks on testing quizzes. Okay? Ever. I'll be very mad at you if you do that. Okay? So to get our last reason, look and see how we marked our diagram. Did we mark 3 sides? Or did we mark 2 sides and an angle in between? 2 sides and an angle in between. So our reason is going to be stacked. Side, angle, side. We have a side, then we have an angle, then a side. Side, angle, side. Okay. Okay. We are going to save that last proof for tomorrow.